Hello, my name is Bryce, and this is my channel Striving Intellect, and today we're going to be talking about volcanoes, both Earth volcanoes and space volcanoes. This video that I'm about to play is actually a volcano on Earth in Grindavik, Iceland, and it actually looks like it erupted on April 1st, 2025. So let's go ahead and let's watch this video. It is absolutely amazing. The different photos and shots they get of this thing, they are very close. Either that or they have a very good lens. But it looks like there's some volcanic rock being spewed, some lava. That is absolutely jaw-dropping. That's amazing. I would hate to be there, though, I'm just gonna say. So that's actually the video. That brings us to space volcanoes. So here's a picture of a space volcano. This is actually Olympus Mons. It's the largest volcano on Mars. It's absolutely massive. To give you an idea, here's another photo of it. It is jaw-dropping. I would hate to see what happens when something that size erupts. That would be absolutely catastrophic. If I had to guess, but it's not like I'm going to be there, so I guess it doesn't really matter that much. But it's fascinating stuff, absolutely fascinating stuff. So this article is actually about the volcano that erupted in Iceland. Volcano begins erupting in southwestern Iceland after nearby town and spa are evacuated. So it looks like they evacuated everybody. That's good. On Tuesday, April 1st, 2025, a volcano erupted on the Reykjanes Peninsula in southwestern Iceland, near the town of Grindavik, prompting evacuations. The volcano, which has been dormant for 800 years, came to life again after the community was largely evacuated a year prior, following magma flows and small earthquakes in the region. Authorities evacuated the town nearby town, where approximately 40 homes were occupied by residents. The eruption started at 9:45 local time, accompanied by an intense earthquake from storm similar to those preceding previous eruptions. I guess there was an earthquake storm or a bout of earthquakes, and that's similar to the prior eruptions. In the initial fissure quickly grew to about 700 meters wide before Iceland's Met Office stated the fissure was about 500 meters long. So it looks like they say it grew about 200 meters. So the fissure is getting wider. While no magma had reached the surface initially, the Icelandic MET office indicated an eruption was likely, and officials urged remaining residents to evacuate. I mean, it looks like everybody evacuated, so that's really good thing, obviously. We can go ahead and look at it again. Lava spews from the volcano in southwestern Ireland, threatening a small fishing town, Grindavik. I mean, it is amazing looking, though. I'm not going to lie. On Tuesday afternoon, the fissure in the volcano had grown to about 3/4 of a mile long, officials said. Grindavik has endangered by 8 of the 11 eruptions since 2021, it looks like. And again, like, it's a good thing that they were able to actually get everybody out. It's fascinating, though. I do think it's absolutely fascinating. The other thing is it's interesting to see that people still live by active volcanoes. Obviously, this volcano had not been active for 800 years before, but it's hard to tell, it seems. It's really hard to tell, and obviously it's a good thing that they are able to get all of these people out way ahead of time. So let's actually go on to the more interesting, in my opinion, topic, which is space volcanoes. Space volcanoes tell the explosive history of Mars, Venus, and multiple moons. Take a tour of the space volcanoes on other planets and moons across the solar system. Find out how they differ from Earth's volcanoes. And that's a picture, again, of Olympus Mons, one of the many volcanoes on Mars. And from my understanding, Venus has significantly more. So I'll go on. While volcanoes have brought profound changes to landscapes here on Earth, volcanic activity on other planets and moons has followed a different path. It's easy to imagine space volcanoes as even more ferocious and devastating versions of the ones scattered across Earth, but in reality, most of them have fallen into dormancy. Volcanic features have been observed on our fellow rocky planets, Venus and Mars, but they largely appear to be inactive right now. Some scientists, however, have suggested that current volcanic activity on Mars and Venus may not be so far-fetched after all, with new evidence emerging from recent studies. So, I guess it's going to go into Earth volcanoes. What gave Earth its volcanoes? Earth boasts more than 1,500 potentially active volcanoes, with 50 to 70 erupting every year. That's a lot. I wasn't aware of that. That's more volcanoes than I want. But why is our planet so volcanically active? The answer lies in plate tectonics, the movement of divided plates that make up Earth's crust. Tectonic shifts caused by heat-driven currents below the crust sculpt the planet's most memorable landmarks, from mountain ranges to ocean trenches. The interactions of plates have also guided magma to the surface and spawned volcanoes, but by moving away from each other, by moving away from each other and pushing against each other. A third process behind volcanic creation relates to hotspots, areas of Earth's mantle where magma rises up from the depths of the planet. When a plate moves over a hotspot, a chain of volcanoes is created. The surface of other rocky planets appears to have been affected by ancient volcanic activity, but this would not have been caused by plate tectonics, a geographical process that is exclusive to Earth, from what we know. More likely explanation is that volcanic features on these planets were created by hotspots like activity or other variations of tectonics. Volcanism on Venus and Mars. Various volcanic features can be found on rocky planets neighboring Earth. Mars containing volcanic plains formed by past eruptions and inactive shield volcanoes that are much more massive than Earth's volcanoes. Like Olympus Mons, the largest volcano in the entire solar system, that's wild, stands 2.5 times the height of Mount Everest. That's giant. This volcano is located in the Terrace region of Mars, which is home to other similarly colossal volcanoes built from basaltic lava that welled up from the deeps within the planet. The verdict on whether or not Mars is still capable of being volcanically active doesn't appear to be set in stone. While the planet experienced intense eruptions over 100 million years, it has since cooled and ceased most activity. However, few lingering signs like Marsquakes, since it's not on Earth, it wouldn't be an earthquake, and magma movement hint that Mars may not be completely idle. The same uncertainty has been true for Venus until recently. While scientists previously believed Venus's volcanoes were inactive, new evidence is starting to push back against this notion. A 2023 study using data and images from NASA's Magellan mission, launched in 1989, found that a volcanic vent associated with Mons, a shield volcano, changed in size and shape between February and October of 1991. Another study published in 2024 built upon this discovery, identifying 2 locations where the formation of new rock may represent solidified lava from volcanic activity between 1990 and 1992. Although this similarly confirms that Venus is still volcanically active, more information will need to be gathered by NASA Veritas mission, slated to launch in 2031 to study the planet's surface. Volcanoes across the moons. Several moons across the solar system also feature volcanic mysteries. Ancient volcanic activity shaped the lunar crust of Earth's own moon, Lunar Maria. Basaltic plains visible on the moon are a result of lava flows filling basins that were left by meteor impacts. Cryovolcanoes on icy moons like Triton, the moon of Neptune, in Enceladus, the moon of Saturn, function similarly to typical volcanoes, but they spew material like water, ammonia, and methane instead of molten rock. That's fascinating. It's like a regular volcano, except the opposite. That's really wild, honestly. Ice space volcanoes on our solar system's moons. That's fascinating, absolutely fascinating. The one member of our solar system that surpasses Earth in volcanic activity or volcanic volatility is Io, Jupiter's innermost moon, containing around 400 powerful volcanoes. Io is influenced by Jupiter's gravitational pull and the pull of the planets on other moons. This tug of war causes layers of rock beneath Io's surface to jostle and heat up, melting solid rock into magma. That's very intense. So the gravity of other moons and Jupiter literally liquefies and melts solid rock into magma, causing volcanic activity on the moon of Io. And it looks like in the solar system, the most that we know of volcanic activity is on that moon of Jupiter, Io. But I'm assuming that the second most volcanic activity is on Earth, which is pretty wild. They said 50 to 70 volcanic eruptions a year with about 1,500 active volcanoes. I mean, it's fascinating stuff, especially ice volcanoes on moons, which is wild. The moon of Neptune, Triton, and the moon of Saturn, Enceladus. Absolutely fascinating stuff. And I actually have just a little bit of an excerpt about Olympus Mons. Looks like it is a shield volcano located in Mars's western hemisphere. It is the highest point on Mars and the largest known volcano in the solar system. It is 16 miles high, which makes it about 3 times higher than Mount Everest. It's also very wide and covers an area larger than an entire chain of Hawaii's islands, which, from my understanding, the largest mountain that is on Earth at all is a volcano, and it is actually the island of Hawaii. Obviously, it's not the highest mountain because it's underneath the water mostly. So it actually doesn't go up above the sea level that much. But that's what I understand about it, that generally speaking, it is actually larger than Mount Everest. But I'll go on. Is very wide, covers an area larger than the entire chain of Hawaii Islands. In contrast, they're about to go over this. The largest volcano on Earth, Hawaii's Mauna Loa, is 120 kilometers across and 9 kilometers high. So it is a significant amount larger, which is pretty wild. It is some 3.5 billion years old, which means that the volcano formed early in Mars's history. It is also a very flat mountain, which slopes only 2 to 5 degrees. That is insane. It's just really, really wide, I guess. The summit is marked by a caldera, which would be a hole in the top of it. Let me see. It would be that hole on the very top of it, it looks like. A large depression formed by volcanic activity spanning 50 miles wide. The summit caldera consists of several overlapping pits. These pits are created by different eruption phases. In contrast, many Earth-based volcanoes typically feature a single, less complex caldera. Key facts about shield volcanoes. They are the largest volcanoes on Earth. They do not form soaring mountains with caldera peaks like composite volcanoes. Instead are broad volcanoes with gentle slopes. They almost exclusively basalt, a type of lava that is very fluid when erupted. Because basalt has a low viscosity, it can flow on surfaces better. So when these types of volcanoes erupt, lava flows outwards in large distances. They are built by repeated eruptions that occur intermittently over vast periods of time. Eruptions at shield volcanoes are only explosive if water somehow gets into the vent. Otherwise, they are characterized by low explosivity fountaining that forms a cinder cone and splatter cone at the vent. Hawaii's shield volcanoes are the most famous examples. Again, I find this stuff absolutely fascinating. Like the fact that there's ice volcanoes on the moons of some of our planets in the solar system. The fact that this is just a giant, giant volcano on Mars that we think is dormant. I obviously am very interested by this stuff. I hope you guys found it interesting too. If you liked the video, please like and subscribe. Thank you.